Hello, Internet. My name is Bret. This is my show. I'm here almost every week on Thursdays at 1 p.m., just right now, basically. And we talk about containers, DevOps, all things Docker, Kubernetes, the cloud, cloud native, all those buzzwords. So thanks for being here. And you get to ask questions of my guest. Usually I have guests or a guest, and I'm excited to talk about databases this week. So thanks for showing up. I see a whole bunch of conversation already happening, people talking about databases, because databases are hard and it's an important topic. And I waited way too long for us to get someone on the show who definitely knows what they're talking about. So today we're going to focus on that topic. Get your questions in early because we kind of go through them top to bottom throughout the show. And this week, I want to remind you a couple of things. One, no, I didn't get punched in the eye. I just have a swollen eye a little bit. And if you didn't notice that, then ignore it. It didn't happen. But number two, I wanted to remind you about DockerCon. So in 2 weeks, we're going to have this all-day Docker show that's replacing the physical event like everything nowadays. We're all virtual events. And DockerCon is going to be huge. We've already got over 40,000 people signed up. And we're going to have at least 3 to 4 live streams all day long. So you'll definitely want to show up because we've got not just a bunch of sessions, but we've also got a dedicated channel for interviews. It's running it is the Cube. If you've ever seen the Cube, just go search that on Google. They do professional level, high-end, quality interviews with executives and all the tech people at the different events. And they're going to be doing the same thing for us, and they're going to be doing it virtual. I have the pleasure of running another channel calling Captains on Deck. And that's going to be an all-day Twitch-style chit-chat where we're going to just hang out, talk about your Docker questions, maybe try to solve some of your Docker problems. And I'm going to have a rotating set of other Docker captains throughout the day. So every hour, we're going to be switching out people. And we're going to have some pretty cool people on the show. I'm excited about the guest list. It's going to be a lot of fun. And you only get to do that by hanging out live, right? I mean, watching that after the event, you don't get to participate. So we're going to have prize giveaways, some swag. We're going to have trivia. We're going to have games. And so we're going to have a lot of fun on that channel. So in between jumping into all the sessions and learning all the latest tech about Docker and how people are using containers today, you can jump back and forth between those channels and learn all that stuff. So you definitely want to sign up. You can just go to docker.com. It looks like this. You just go to docker.com, sign up. It's free. There's really no reason to not do it. And of course, all the sessions will be available later. They're going to be streaming on YouTube. So yeah, come hang out with us and check it out. All right, next up, just a reminder that this show is sponsored by my Patreon page. So instead of having a 2-minute ad for some other service, I thought you might just want to check out the fact that I put a bunch of this stuff on the internet for free, and I do courses that you can check out, obviously on my website. But really, this show is the way to thank me for this show is to just buy me a coffee there, essentially. You basically pay a couple bucks a month, $3 to $5. It depends on what you want to do. And you don't even have to pay money. You can actually go to Patreon and just click follow, and then you get all my updates throughout the week, all of the open source, like I did last week. I did some Java open source Docker examples. You can check that out. And then this show and the podcast and all the other things that I'm doing, you can find out there on Patreon, even without giving me anything, which is great. You don't have to. It's no obligation. But if you want to thank me, please do so. All right. Let's get to this show because today's topic is really important. I think all of us have to deal with databases. And I don't know, a couple of months ago, I put out a tweet saying, "Hey, would you like to be on my show? If you have something in containers you want to talk about, show up." And Andrew was lucky enough to get in early, so we got him in the list before everybody else got on the waiting list. And I was excited to hear that he wanted to be on the show because having all that DBA background is really important, I think, for containers as we all learn how to run databases there. So welcome to the show, Andrew Pruski.
Thank you very much for having me, Bret. Really
And you're a Microsoft MVP for data. What is it? Data platform. Yeah.
Yep.
So does that mean you're supposed to know stuff about databases?
A little bit. Yeah. They tend to award it to people who also help out in the community, but it's for technical knowledge as well.
Yeah. I think it's very similar to the Docker captains. We're basically like the Microsoft MVPs of Docker.
Yeah, I think so. Yes.
Yeah. I think the rules are you can't work for Microsoft, right? And then you have to talk about something nonstop, and then you have to also know a little bit about it. So
yeah, pretty much. And I pretty sure I got my MVP by talking about SQL Server and containers, because that's pretty much all I talk about when it comes to like the community platform.
Yeah. And you've talked at DockerCon. We talked about that before the show. We didn't actually get to meet up in 2018, I don't think, but you were in Barcelona, and we had like like 3,000 to 4,000 people there. I think at least it was a lot of people.
No, it was massive. I've been presenting a while now. I still get a little bit nervous before I do the smaller events, but I remember being incredibly nervous before I started talking at DockerCon. I was in the community theater, and there was all these people, a couple of hundred people all sitting there looking. And I was it's only a 20-minute session, but I remember distinctly just before my session started thinking, why do I do these things again?
Why do you put yourself in that pressured situation? Well, and DockerCon, DockerCon tends to have really big sessions. They don't do, a ton of sessions all at the same time. So usually wherever you're at, you definitely get an audience, and that can be my biggest audience has been at DockerCon, where it was a big room, and luckily I couldn't see them all because they do that whole thing on the stage where they shine the lights on you.
Shine the lights, yeah. So you can see maybe a little bit, but yeah, right. I don't know if that makes it worse or better.
I don't know. I feel like it makes it better, because if I could see all those people, like I probably would be worse than I am. I mean, I already stutter on stage nonstop, and it's full of ums and uhs. So
I distinctly remember panicking. I had a couple of demo failures where Visual Studio Code decided to throw a couple of errors at me, and I just remember standing there even and saying, "Okay, right, we have to restart this." And well, fingers crossed, hopefully everything now works.
Yeah,
but everything seemed to got through it, and everyone was really positive afterwards. So I was really pleased.
Yeah. I was trying to remember what was the ritual for the demo gods in Barcelona. Because like every DockerCon, there's that they always on stage, on the main stage, they always do some sort of a tribute to the demo gods so that our demos don't fail. And I can't remember what it was for Barcelona. They've had fortune cookies in San Francisco. They've had, I think it was Legos in Copenhagen. They did a little, because I think Legos are maybe they had stickers. Oh, maybe they did stickers there. I don't know what they did where they did the Legos. Anyway, so what was your session about at DockerCon?
It was Docker and databases. So I'm a SQL Server DBA, so I based it on using SQL Server running in a container, and it was a mainly demo-based session. I was there in front of a lot of people who've used Docker, so I don't want to go through the theory of it. I wanted to show what you can do with running a relational database system in a container and the benefits that it brings. Databases are tricky. Say in development environments, you usually have a whole bunch of database servers, and they have to be kept up to date. They have to be managed. Are they in the right state for the application that you can deploy them to? And Docker kind of fixes those issues for us. We can build a container from a known image and deploy that container. We know exactly how that SQL instance within that container is configured. We know the databases are at a certain level, and we can spin that up and just let everyone test against it. When we're finished with it, boom, it's gone. So that's what I wanted to show when I did my session at DockerCon.
Yeah. How did you get? What was your first container? Like, was the database your first container? I'm guessing you had some at the beginning before that.
I remember here first time I saw Docker, I did the whole Hello World thing, and I sort of downloaded it and spun it up, and then I spun the whole Hello World up and looked at it and went, great, and then went back to being a DBA.
Yet another way to run an app.
Pretty much. And then a couple of years later, Microsoft started announcing the whole Microsoft loves Linux. Microsoft started releasing SQL Server images for us that would run in containers. We started looking at it, and I've been having this whole problem at work where my QA and dev department used to refresh their development environments on a periodic basis. They'd blow away their environment and rebuild it. And their environment was basically a load of VMs with a full production stack on them, each one of them wanting a SQL Server instance. So they'd install SQL, let that run, get it installed, and then restore a load of databases from using PowerShell and from a load of scripts held in source control. It wasn't exactly the quickest process in the world. We're talking anywhere between 40 to 60 minutes to get SQL installed, and then we're restoring databases. There's a little bit on top of that, mainly because they wanted to pump data in and all these bits and bobs. And it wasn't the most reliable process in the world either. It was prone to failure, and when it did fail, dev is left trawling through SQL Server error logs, trying to work out what went wrong, and trying to fix a busted instance of SQL Server can be a little bit tricky. So I even saw a dev just blow his whole VM away and start from scratch. So that's when I started really considering like Docker technology. What if we didn't have to install SQL Server anymore? What if we could just spin an instance up immediately and have it configured exactly how we wanted it to be with all of our databases ready to go? And pretty much that's exactly what we did. We got rid of the SQL instances and all those VMs, moved them off to a remote host where Docker was running, and started hitting that instance saying, I need a new container with SQL running. Bump that came up, applications connected to it, and we're good to go. And I remember we took it down from about 40 to 60 minutes to refresh a VM down to about 2 minutes. So I think the CTO said at the time we were saving a month of developer work a year just from that one change.
Right. Just the spin up time for sure.
Yep.
And okay, so a lot of people are still very pessimistic about databases and containers. And, from my point of view as a sysadmin, as long as you know the tools, like in this case, just knowing Docker, I've always felt like, applications are just applications. They, containers don't change the way the application works necessarily. But obviously, we have to worry about persistent data. So we've already got questions in chat about persistent data. Are there, in your mind, like after years of doing this, are there still reasons why you wouldn't want to use a container for a database?
Production is a little bit tricky. Development, absolutely. I would 100% recommend using SQL Server in a container for development environments and your CI/CD pipeline up to a point. When it comes to production, you need to start thinking a little bit more. We need to move away from Docker a little bit. We need to get an orchestrator involved at some point. We need to maybe looking at Docker Swarm, Kubernetes, and because one thing we found when we built this system was we have Docker installed on one host, and what happens if that host goes down? And that happened a couple of times. We came in the morning one day, that Docker host is down, the entire QA department can't do their jobs. So if we'd had, say, an orchestrator involved, everything would have shifted seamlessly over, and we'd have been running.
Yeah.
So at the moment, the technology I work with, we're looking at using SQL Server in Kubernetes at the moment. It's still early days, but it's very promising. But the one thing about containers and Kubernetes and all this stuff is it's just another platform that we can use. So it has its pros, it has its cons, but we have that option if we want to. So I'm not saying use Kubernetes for all of your databases, but there might be certain instances where it would be of an advantage. So a lot of programs come with, say, install a database by installing SQL Express, and you have SQL Express running on the VM. Why not point that at a container running in Kubernetes? You don't have to worry about managing it. You've got your high availability going on. All you got to do is probably set your backups and maybe a little bit of maintenance. But instead of having all these instances dotted everywhere running SQL Express, have them all in your Kubernetes cluster. That would be a very, very good way of using it.
Yeah. And part of the challenge is, to me, databases are the hardest apps in general, right? Like on any server.
They have that really annoying thing called data in them, which throws a spanner into the works.
Because they tend to be very resource intensive in comparison, right, to other random apps. And then they also have all these persistent data requirements. And then because they're usually the backbone of every app, they also have redundancy requirements that are, basically persistent state as well as persistent data. And it just it's a combination of all the things that are still hard about managing systems, right? And so now you've added layers of other things like Docker and Kubernetes and stuff on top of it. So I can see how, like, even for us that have been doing this a long time, there's just so much understanding all the way down the levels of tech that you have to make versus, like, it wasn't that long ago that I was installing, Microsoft SQL, 2008 on custom built servers with, custom RAID sets optimized for logs versus databases. And we had, they were in a data center or at least in a rack in a closet somewhere. And you never wanted to touch that server or its replica because you're not really sure if you could recreate it. Like, it was a snowflake unique environment. And you certainly didn't have all those specialized hardware setups that you had designed just to get the peak performance. And nowadays, it seems like so many people are just talking about like throwing databases on a cloud server with nothing with no worries. Like it's all the problems are solved now. But when we also get into production, I find that none of those problems are really solved, and they still have to care about all those things. It's just on someone else's platform.
Well, one of the good things I think of, one of the great things even about this type of technology is it separates the data from the application. So I don't care about what's accessing my data really, as long as it
Hmm.
can be accessed. So if that SQL instance dies, I don't care as long as I've got my data. So I can spin up a new instance of SQL and that can access my data. So the application layer for this is, I don't really care. It's the cattle versus pets type of thing
Yeah.
where we used to nurturing our SQL instances and tweaking them and lovingly caressing them and making sure Docker technology changes that by making SQL a throwaway object. I don't care. I
Yeah.
can spin one more of you up in seconds. What I really care about is my data. And I'm going to focus on where my data is stored. Is it backed up? Is it performant? The application itself, I know I can spin up a configured instance of SQL really easily. So I don't have to worry about that side anymore. It's all about the data.
Now, do you run more than just Microsoft SQL? I'm assuming that as a DBA, you're kind of given a bunch of stuff to deal with.
I'm very specialized in SQL Server. I have messed with other ones, some NoSQL databases like Redis, MongoDB, and MySQL, but I would not describe myself as an expert. I'd be an enthusiastic Googler in working out how to get those running.
Yeah, I mean, but I feel like from the people that I work with and the clients that I have, the people that are on the Windows side are a little bit um, behind the people that are on Linux. So we have like a lot of people that are, they've been running MySQL maybe or Postgres in containers or Redis. I mean, Redis
Mhm.
is a little easier because a lot of people don't even care about keeping the database in that a lot of times because it's just a queue sometimes. But
Uses a cache. Yeah.
yeah, and Microsoft eventually said, okay, now we have Linux, Microsoft SQL, and then they had their traditional regular Windows container SQL. Are you when you talk about Microsoft SQL, is it both of those? Is it just the Windows container type, or what's that all
I
about?
I would 100% say I'd be using SQL Server Linux containers. The technology is just more advanced, more mature. The Windows containers are there. The SQL images aren't getting quite as much love as the Linux images, and I just feel that if I was going to go and use SQL running in a container, it definitely would be on a Linux platform, just just
Yeah,
because of how mature it is.
even though it's technically a much newer product, right? I mean, that product's like what 3 years, 4 years old, maybe.
It is. It's basic. I'm there's something called the platform abstraction layer in SQL Server. So the code in Linux is actually the same code as on Windows, but
Mm,
it's got this what's called the PAL running underneath it, where it doesn't matter if what platform it's on. So the code everywhere is exactly the same.
interesting. I didn't know that. So that sort of ensures that you're getting um, all the years and decades of code revisions and enhancements, but it's not a complete rewrite from the ground up.
Absolutely, they haven't had to change it to make it run on Linux. They've just slipped this layer in underneath, so the calls are converted as they go down. So you've still got that SQL Server engine that we've all come to know and love over the
Yeah,
years. So
yeah, yeah. So are you taking traditional Windows run databases from like a Windows Microsoft SQL and then moving those over to a Linux-based Microsoft SQL? Is that
you
something?
you can take you can take a database that's running on Windows SQL Server and restore it into SQL on Linux and run it in a container. Absolutely no worries at all.
Oh, nice. Is there a version compatibility kind of thing going on there as well?
Not at all. Well, as long as they're at the same level. So if you're running SQL Server 2019, you restore into SQL Server 2019. 17 can go up to 19, but you can't go backwards. But
Oh, so it's
yeah,
a parallel version number. In other words, they both have the same year of release. There's not a different release cycle kind of thing.
absolutely. Yeah.
Okay, very cool. Well, we definitely have some questions on this, and I think people are going to want to jump in really quick on exactly how all this works because I for one, as a traditional old school, I call myself a part-time DBA. Like I never really did it full time, but a lot of us that are sysadmins or developers, we've always had to run databases when there wasn't a DBA around. Like we'll do until a professional can show up and do the job. So I've had a lot of experience over the years, but always didn't really know what I was doing. Um, and it's great to dig into some of these details because I think some people might be skeptical that they would take their Microsoft database that they've been doing this stuff for decades and to just shift that over to a completely different OS, and the idea that could actually be as stable or even better on that platform is a pretty interesting idea. So I think the first one here was someone was actually asking about init scripts for creating databases during container initialization. Can you talk a little bit about that?
So is that when we spin up the instance within the container, we want our databases there ready to go?
Yeah.
So there's a couple of ways you can do that. You can have scripts. So SQL Server can execute store procedures on startup. So you could put store procedures in there to say, oh, if there's backup files in this location, restore those databases from there. You can run. You can just snap the instance as an image, and when you spin them up, the databases are there. Or you can write a custom script, and I've got a couple of them on my blog. They'll go off, and when the instance comes up, it'll kick that script off, go off, restore your databases, and boom, you have your databases there ready to go. It's I think it's the key feature of running SQL Server in a container is that I don't have to do anything else. Once I hit Docker run or the application kicks off the container for me, that instance is there ready to go for me. I don't have to do anything else to it. It is ready to go and start working on it.
Nice. And this, I'm assuming when we're talking about this image, we're talking about the it's the Microsoft MySQL Server image, right? Under
That's
Hub.
the one.
Yeah.
It's not on the. They're not on the Docker Hub anymore. They're on the Microsoft Container Registry. So they'll give you the details there, and they've got the image tags. But you won't be pulling from the Docker Hub. You're pulling from the MCR. But it's compatible with the Docker Catalog API, so you can do like a curl against a URL and pull out. Yeah, exactly. All of these images here.
Yeah. That's a pretty cool spreadsheet view. I don't think I've actually seen that on other Docker images, detailing all the dates and the versions. So 2019 is the latest.
Sorry, yep.
And when we talk about this, I know like traditional Windows SQL, there's reporting server and there's all these other additional components, not just the database endpoint. Is that something that's also in Linux, or are we really just focused on the database endpoint here?
We've got the database engine, we've got machine learning services, so you can run like Python and Java and R scripts against your SQL instance. The reporting services, analysis service, and I think integration service, I don't think they're there yet. They might be coming in the future, but I couldn't comment.
Yeah. And I know that neither one of us are salespeople, but I was always curious, how does the licensing work on Linux? Is it roughly the same as Windows, or is all of this free, or what are we?
So we have we have different tiers. So there's Express, which is free. There's Developer, which is free, and there's Standard and there's Enterprise. And there's a couple of others as well. Standard and Enterprise are paid editions. They're licensed. I'm going to go with 90% sure they're licensed exactly the same as Windows.
Yeah,
pretty sure. And then if you're licensing, say, things like containers, they are licensed the same as VMs. So you license the host they're running on.
Right. Yeah, they have some, for those that are going to check this out, they have some requirements on the environment variables, it looks like. So you have to make sure that you set those or it won't start. So that'll be the first thing we all want to look forward to, is making sure we have those.
You need to accept the end user license agreement. You need to do that every time you run SQL Server in a Docker container. I've been told it's a legal thing. And then you need to set an SA password. There's no Windows authentication for SQL running in a container. So set the SA password, and that gives you the ability to go in. And then pick your version. It'll default to developer, but you can switch it. So.
Oh, okay. So it's one container for all the different licenses. Interesting.
Yep, you can just switch as you go.
It certainly saves me the download time. Downloading all the different versions for servers back in the day. So we had a question around, this is a pretty good one. Is it better to use Amazon RDS for SQL Server or versus Microsoft SQL Server in a Docker container?
That is a big, massive, it depends. I'm afraid I couldn't possibly. Both of them have their pros and their cons. Amazon RDS is going to give you a completely managed service that's at an enterprise level. So you can go off and you just throw your databases in there, and it will pretty much look after it yourself. I'm pretty sure they have automated backups, they have automated maintenance. At least I might be straying into Azure territory here, but those types of cloud offerings, that's what they do. With SQL Server in a Docker container, well, you're looking at running your SQL instance in a container and locally. So what do you need from that as opposed to running it up in the cloud? Is it easier for you to do it locally? If you want to do local development, maybe it'll definitely be cheaper. But you can throw something up in the cloud, then you maybe got an enterprise edition up there. So swings and roundabouts. It's a massive. It depends. I'd need to know a use case really for me to be able to answer that fully.
Yeah. I think, I mean, if I had an opinion and I didn't know your requirements, or whether you had a DBA team, or my impulse is always use the cloud hosted version first. I mean, when we start talking about containers and container orchestration, I mean, Andrew will know that there's a lot of work there. And so if I've also now got to take a way to figure out how do I move that storage back and forth, all that stuff. Yeah, it's a lot. I would much rather the cloud do it for me.
If you have infrastructure in the cloud, if your applications are there and you need a database to spin up and access, absolutely go into the cloud.
Yeah. It's also, sometimes we have to worry about job protection, job insurance, and having my stuff outsourced to the cloud provider in a lot of ways removes a little bit of that responsibility. Like if the backup job failed, it's not entirely my fault because I didn't fully test the script or validate it through some monitoring tool. Like there's
this is something that's been going on with DBAs for years. A new technology will come out and say, well, this will spell the end of the DBA. And it's been going on since I've been a DBA, which is now 10 years. So
right.
Query Store and SQL Server came out. We no longer need to dive in, and it'll do an automatic plan regression correction. It'll fix plan regression for us. Up in the cloud, it'll do our backups for us. But you still need people to know those technologies. And those people generally are DBAs. So
yeah, I mean, I think that it's very similar to the pattern, I think, for sysadmins. I mean, 20 years ago, one sysadmin could not manage 300 servers really, right? But nowadays, spinning up 300 I can spin up 300 instances in 5 minutes on the cloud. I do it whenever I do workshops. I did a workshop a couple weeks ago. We spun up, 50 different clusters of Kubernetes or 70 clusters of Kubernetes, and I tore them down at the end of the day. Like it. To do that 20 years ago took a lot more manpower. So to me, it's always just a question of, it doesn't replace any of our jobs. Traditionally, I've seen that this stuff doesn't really replace it. It just allows us to manage a lot more. Now, sometimes in small environments where maybe there was one DBA, that DBA maybe doesn't need to be a full-time DBA anymore, and they can take on more job responsibilities. But I don't tend to see a lot of, companies doing away with an entire job role just because the cloud created something. Usually those people just have more work to do in different places that already needed to be done to begin with. It was usually just not getting done, right?
The cloud takes the menial tasks away. So like the backups and the maintenance. And then I don't have to spend my time worrying about fixing, this database wasn't backed up last night. I need to go and back that database up. This maintenance job didn't run. No, that's done for me. I can now concentrate on some other projects of improving performance, or some automation tasks that I want to do to get into the nitty gritty. So it takes the menial jobs away from us. I've always felt.
Yeah, that sounds like a great description of the cloud, is taking the boring stuff and putting it in someone else's job. Yeah. Let's see. When using a database in containers for production, how is data files are persisted and shared between containers?
So with Docker, you have multiple different options. You can mount from the host. So you can share a volume from the host, bind mounts they're called, display them into the container, and then you can reference your files. That works really well for, say, if you have a very large database, you want to do stuff like that. Or you can use named volumes, where you create a volume within the Docker ecosystem, as it were, and reference that. And those life cycles of those volumes are independent of the containers that you spin up. So you can spin up a container, blow it away, spin up a container, blow it away, but those volumes are still there and still referenced. So once you spin up your new container, it can reference those databases at that location. That's how you can share them from container to container. It also makes doing things like upgrades of your SQL instances really, really easy. Blow away the old instance, spin up a new one at the higher version, and boom, there you go. You've just upgraded your SQL instances. Instead of having to download an MSI, double click it, sit there, wait for it to install. You've done it in
Right.
a few seconds. And what's really cool with CUs for SQL, the cumulative update, sorry, for SQL Server is with Docker containers, they're backwards compatible. You can, oh, I've upgraded, or I've noticed an issue. I can roll that upgrade back. Whereas installing on Windows can sometimes be really, really tricky uninstalling that CU. So we have the ability to easily share data across containers using bind mounts, name volumes. There's even data volume containers if you want to get that far. But you can share your volumes between containers really easily, and it has so many benefits for upgrades, rolling back, things like that. It's absolutely fantastic.
Yeah. Um, the a lot of times for people, once they get into orchestration, the challenge gets to be around what's going to make sure that my databases are on the host where the container runs. Are you doing something in house? What are your recommendations on that? Like, I know there's going to be different solutions in the data center versus the cloud. Sometimes the cloud can do some of it for you. Um,
So where the container is to where the actual data volumes are.
yeah, like once we get to orchestration, one of the challenges is, okay, well, wait, if my database is over here and the data is over there on that server node one, and then my container crashes, or I upgrade it, or I spin up something new, I change the config, so I need to redeploy it, and then it picks node two for this server. How does my data get over there? That's a common question I get a lot from the students in my courses.
So for say like Azure Kubernetes service, it'll actually migrate that volume. So the volume will get attached to the node that the container is running on. There's an issue with that node. You'll see the detach and attach controller actually take that volume and attach it to another node within the cluster, and then your container will spin up. Now you need to make sure that you have your like rollout strategy set correctly. So with SQL Server, you'll typically run in one pod in a deployment. So you need to make sure that when it goes down, that's going to move across. It'll bring your pod up, and you're good to go. Running, I mean, it's going to get a little bit trickier if you're doing that in-house. So maybe you want all of the nodes to be able to access a central location to make sure you have enough bandwidth going down from all the different nodes, so you don't see a degradation in performance if your pod moves from one node to another. So there's a load of different things that you can take into consideration. But running up in the cloud pretty much does it for you, as long as you get things. There are little tweaks you can do in your deployment, but as with anything, throw a database in there, turn the node off, see what happens.
Right. Yeah, I mean, obviously, you can. Everyone should be playing with this stuff for a long time before you even consider stuff like production. I mean,
Yep.
Andrew's been very conservative on taking this stuff to production especially with orchestration and those higher level tools, because almost all of these database technologies, Microsoft SQL for Linux included, were not necessarily created post-container world, right? Like the idea of a database engine that just runs anywhere and it can find its data magically, or that it somehow auto-replicates the data itself and takes care of that problem. We don't see that a lot yet. There are new projects out there. We've got like CockroachDB, which I think is probably one of the more popular ones, that is trying to be that you just run up a bunch of containers and they all kind of find each other, and it's supposed to be this magical solution. I haven't had a pleasure of actually trying it out, but I think over time these older database technologies are slowly starting to adopt to this way of, like you're saying, the application is unimportant. It can just be thrown away. The databases can spin up in different versions as long as there are minor changes or something in the versions. And that it's not so hard. For example, things like mirroring or replication, getting those sort of things set up. So I come from a world of like 15 years ago, setting up replication in Microsoft SQL. There was all these different ways you could do it, right? And they all had pros and cons. And some of them, like, there was manual failover and dynamic failover and all these different complicated read, write, read, all that stuff. Have we reduced that at all in the Linux Microsoft SQL space? Is there like one preferred way in containers to deal with fault tolerance?
So there are a few different ways of high availability for SQL Server. So there's things like log shipping, which is supported on Linux, which is you're firing the transaction logs and restoring them over to another instance. There's always on availability groups, which is basically mirroring on steroids. People I've heard people call it what mirroring should have been back in the day, where it's built on clustering. But if you have an issue with your node, your primary node, basically if that node goes away, your databases will fail over to your secondary node. Now, the benefit of if you're running this in, say, an orchestrator, benefit of that when you've got that Kubernetes high availability already built in, that swings roundabouts a little bit. It all depends on how quick you want your databases to come up. What's your RTO? What's your recovery time objective? Do you need that up immediately, or can you take a little bit of lag?
Right. Are there? Okay, so we had actually a really good question related to this. It was Tommy asked, how do people manage database backups in the orchestrator world? Is there some built-in functionality out of the box for backups?
There's no built-in functionality. I mean, you can snap your volumes that you're using, but it's just another platform that we're running our database technology on. So I would always say highly, highly recommend. In fact, I would 100% just back up your databases as you would in any other platform. They're just another platform where we're running our databases. So if you're taking fulls, you're taking diffs, you're taking log backups, you continue to do so when you're running in an orchestrator.
So in your case, would that be, let's just talk about Docker for a second without all the orchestration. Would that just be you running like a Docker exec in the container with the database dump or backup commands, or would you maybe recommend running it across the network in a different container where you do a Docker run and specifically a backup? Does it matter?
You can enable the SQL Server agent in a Docker container which is the job scheduler. So you can stick jobs in there, and they can back up to a name volume or a bind mount. Then you've got your backups.
Oh, nice. Is the agent, and that's not new, right? We've had the Microsoft SQL agent forever. It did all those kind of, it used to have that little workflow tool as a GUI. Can you connect all those, by the way, I was just realizing, can you connect all those GUI management tools to the Linux version of MySQL? I'm assuming that's a yes.
Absolutely. So if you're, actually SQL Server Management Studio, which we've had for years, you can't run it on Linux, but you can connect it to SQL Server running on Linux, no problem. But we now have things like Visual Studio Code. We have Azure Data Studio. Those are cross-platform that we can use to run on a Linux box. My actual primary workstation is Fedora, and I run there. I wouldn't have been able to do that 6-7 years ago, even purely because all the tools were Windows-based.
Yeah. What a world we live in. So that's SSMS, right? That's what you're talking about?
That's Management Studio, yeah. It's been a really exciting time to be a DBA over the last 5 years with all these different platforms coming out. Linux, we had obviously in Docker containers. We have got SQL managed instances in Azure. We've got Amazon's RDS, Azure SQL DB. It's really cool to have all these different options, which we didn't have before. So I think when you said earlier, like, is the cloud taking away DBA jobs? Not really. Look at all the different things we have to work with now.
Yeah. Yeah, there's a lot of tools there that are oops. Oh, I tried to post something in chat and it's not letting me. I'm going to put the comment down here in chat over here. The database tools are like the GUIs I think are better than ever. I don't care what database you're running. Because I've got all, like, being a consultant, it means I kind of just got to work with the databases that all my clients have. So I typically have every possible database tool that, whatever platform is running. And, it's funny, some of them aren't free, some of the good ones. And you end up paying for it, but you only use it like once every 3 or 4 months depending on the client. So I've always loved the Microsoft SQL tools. It was great once they made them a separate download and it was free, and you didn't have to worry about like installing it with the server. Making sure you didn't install the server with the thing. It was always a problem. You can tell how old I am. I have a lot of gray in my beard, so I've got old SQL stories. So I wanted to just mention something while we were here talking about database backups. And I don't know anything about backing up databases with Valero, but we had a show on this channel. So on this YouTube channel, you can go back, just click on the videos, and you'll see just a couple weeks ago, we had someone from the Valero team on to talk about Kubernetes-based backup. Essentially, it creates jobs in the background. So it's like a cron job type of automation. And then it has features for different types of workloads. And I don't know whether they have a Microsoft SQL version of that. I don't know if you've ever looked into this.
I haven't. With these types of tools, you need to be a little bit careful because if they're just going to snap the persistent volume while I/O is happening, you're not going to get a recoverable database. The
Right.
database will be in an inconsistent state. If they are, say, quiescing, so freezing I/O in the databases, you'll get the database in. You'll get a backup with a recoverable database. But you just need to be careful because that I/O will get frozen. So that will
Yeah.
affect transactions coming in. So it's the same as anything. Test, test, test.
Yeah, that's a really important point about the quiescing because um, that I feel like that was a lot of tools we've had in the past on the Linux side didn't necessarily do that sort of I/O level snapshotting. They always did sort of a traditional exporting a .SQL file like MySQL dump stuff like that. Where on the Windows side, and maybe I'm totally wrong about this, but I've always felt like as a Windows admin side for Windows versions of Microsoft SQL, we had those tools that were actually more integrated into the Windows operating system that would allow us to get true hardware level snapshots. Especially if we had separate sort of like iSCSI disk, like NetApp solutions and stuff like that, where we could do
There's
advanced
the
stuff like that.
VSS backups, which will quiesce your database to get the consistent snapshot. But with SQL Server, I would always say use the native tools to back up your database. You back up your volumes, yes, as a secondary backup, but you're running SQL Server, it has native backups. There's no reason why you shouldn't use those native backups to recover your database. They really are the best tool for the job.
Yeah. All right. Let's see what other questions. These are all great tips. How do I preserve the configuration? Okay, so some people are asking about configuration, specifically, if you're spinning up these databases and you have all these configuration settings, how do you get those in? How do you preserve them?
So when I first started doing this, back when we were spinning up for our QA environment, I actually just had a scheduled task in Jenkins that would spin up a container for me, do a load of checks, make sure that it's all the settings were configured correctly. Then it would pull from source control all the scripts that were applied during the week to those databases to bring them up to the latest version of production, and then snap it. And that was my new image for the week. So when people came in on Monday, they were ready to go. If they wanted to redeploy, they could redeploy with the latest version of all the databases there. So yeah, I just had an automated process running in the background to spin me up the container of the previous version, make all the changes, snap it, save it back. We're good to go.
Nice. Yeah, there's
I can see the question there with the updates, and I don't want to manually reattach all the MDFs. So that I used to do a presentation where I showed the persistent storage of SQL Server. So I used to be able to take the volumes over from one container to another, and then I'd run an attach script to reattach all the databases. If you persist where the master database lives in SQL Server, I think it's var opt MS-SQL Server. Sorry, it's var opt MS-SQL data, where the master database lives. The master database holds records of where all the user databases are. So if you persist that from one container to another, and you take the master volume and the user volume across, when SQL starts up, it'll read the master database and go, oh, I've got databases in this location, this location, and this location, and automatically attach them for you.
nice.
Yeah.
And
so there's no need to manually reattach all your databases.
right. Good question, Biker. He's always got good questions. When scaling a database running in containers, do you start more containers sharing the same data, or a cluster must be configured and new containers added as slaves?
So with SQL Server, we don't have the ability to shard our databases. You can do something called always on availability groups and have read-only replicas, so you can offload read transactions, but the writes, you can't shard them. They have to go to that one database. So that's kind of what it makes it tricky with containers, because ideally with containers you want to horizontally scale, but with SQL you can't really do that unless you're just doing horizontally scaling reads. The writes only have to go to the one source, I'm afraid. So that is a limitation there.
Yeah. And there are some questions that people are discussing around, having two containers talking to one set of databases. I don't know any technology that supports that, actually. That's having two applications.
No,
yeah.
I've tried. It doesn't work out well.
Yeah. So yeah, you have to set up multiple containers with separate copies of databases and all that stuff.
Yep. You just get that. You'll get those conflicts at some point.
Yeah.
It'll just say that if you reads, maybe if you're lucky, but writes absolutely not.
Yeah. Maybe. Yeah, you might. but still, even then, like Microsoft's not going to support it, right? They're going to tell you that that's not a supported
They'll turn
workflow.
around and go, well, what did you expect? Silly.
Yeah, even on read only. There's a question here that's pretty specific to Swarm. How do you handle volumes with Microsoft SQL when using Swarm? Rexray seems dead. So the challenges with Swarm are that not a lot of storage vendors are actively pursuing projects on Docker and Swarm. We're actually Mirantis, the company that split from Docker, they have said that this year they're going to be working on some storage plugins for Docker and Swarm, essentially to sort of update that plugin architecture. So for now, there are, I'm sure people in chat maybe have already answered this question, but there are other third-party solutions. You can look at Portworx with an X. There's Storage OS, I think, and maybe some some other ones. Basically, you just kind of have to Google around and see if you can find some open source projects that will do that. But essentially, once you get to that level, I'm probably going to steer you towards a cloud-hosted Kubernetes environment where that's where a lot of the storage vendors are putting all their effort right now. Maybe eventually, yeah, we'll see that they'll come back to Swarm once people get over the Kubernetes hype.
Swarm's biggest problem is Kubernetes at the moment. People seem to be piling their efforts into Kubernetes, and not without good reason. But people like Swarm. Swarm is a lot easier to get set up, to be honest. And there are good things about Swarm, but that's the problem it has. Is Kubernetes has just dominated the market now, so everyone's focusing on that.
Yeah. Yeah, it's a shame. We actually talk a lot about Swarm on this show because I feel like there needs to be multiple orchestrators. Like Kubernetes can't solve everyone's problems, and that's actually one of its challenges right now. Is it's very unopinionated and it's very flexible, and it can do such a wide array of things that's really actually challenging for a lot of people to get started because there's so many features, and there's so many things you can do with it that it's a little overwhelming to make the choice. Whereas Swarm is very opinionated, has a very small subset of the functionality, but it's like that 80-20 rule. It solves a lot of people's problems, and I wish I had a better storage answer for you. At some point, I probably should just do a show on what works currently in Swarm with storage, because there's at least 2 or 3 projects that are out there that you could come up with that would work. All right, we talked about backups, so I got that question. Is it possible to recover crashed master database inside container as the master crashes, container goes down?
Well, that's a big it depends. I mean, you can recover a crash master database in a SQL instance, yes, under certain circumstances. So there would be no different. I mean, I wouldn't bother. I would throw that instance away and spin up a new one and then reattach the user databases, because why bother trying to fix that? Bring it in, you still have your user databases, slip a new instance in, reattach them, you're good to go. That's a really cool thing about SQL Server in Docker. I don't have to worry about fixing those issues anymore. Oh, my master database has crashed, my instance is down. Okay, well, get rid of that instance, bring me on a new instance. Okay, at that point, I'm probably going to have to manually reattach my NDFs and LDFs, but it's better than trying to figure out what happened with my master database for how long.
Right. Yeah, there's a question about persistent resources in my Kubernetes mastery course, which the short answer to that is yes. That's one of the upcoming sections in my Kubernetes mastery course that we'll be working on here pretty soon. We're already working on it. And what could they look into on persistent storage and volumes? I'd say first go to the kubernetes.io documentation. They got tons of stuff there. You might look back at some of my prior Kubernetes episodes on this channel, because we talk about Kubernetes a lot. So there's like the Valero topic talking about backups and databases, and that's all related to persistent data. So you definitely want to, if you're going to have to do persistent data of some kind, you're going to have to back it up. So you got to, those two things like backups and persistent storage are 2 parts of the same problem, and you need to know both. So you definitely want to watch that episode. Other than that, I don't really have anything on top of my head. Let's see. What is the general logic of a Microsoft SQL cluster? This is semi-related to your the replication topic, but what's the general logic of a Microsoft SQL server? Is the relationship between nodes? What is the relationship between nodes, and does it support master?
So cluster is there's two different types. There's a failover cluster, which is basically one instance and two nodes, where the instance will actually fail over from one node to the other. So that's just a master to the same master. Then you have something like always-on availability groups, where it's two instances. One is the primary, one is the secondary. Primary has it, and you can have, I think it's up to, there's 8, I'm going to say. Don't hold me to that. But if the primary has a problem, it'll fail over to the secondary, and the secondary at that point will take over. So it's basically replicating that data across.
Is that per database or is that per node?
It's per availability group, which is a one or more databases.
Okay, right.
So you have this logical structure, which is a availability group, and you put your databases into them.
Nice. I have vague memories of when that first came out. Let's see. Yeah, someone on the storage topic, someone's mentioning GlusterFS as a data store. I have not used that in any real world scenarios, but I hear people that use it. There are other projects that are related to GlusterFS. Let's see. Someone asked a question about a little bit related to this. It's more about networking and cloud permissions. But if I have a cloud-hosted database inside of VPC, how can my application access the database if it's running in an orchestrator?
So you can, if you're running, say, SQL Server, now you'd use a load balance service, which would give you that external IP, which I'm pretty sure you can limit within AWS as well. So when I say public IP within your infrastructure, so it's not out on the internet. So load balance service is probably the way I'd go with that to get that external IP, and then you can route your connections in. Just off the top of my head.
Yeah, I'm thinking there's nothing special. I mean, to me, an orchestrator is just running in EC2 instances. I mean, if you're running Fargate, then technically you don't have access to those instances, but you can still access endpoints. And so, like, if it's an endpoint on your own EC2 run SQL Server, or it's an RDS automated running solution, like they give you the endpoints, and it's just a matter of the security groups.
Yeah, it's just, and then it's down to your security configurations. Yeah.
Yeah. Right. Oh, so the comment here right now. Okay. Yeah, they're talking about the swarm constraints. I think that's it. Okay, I think we've caught up on all the questions. So this is the last chance. Get your questions in if you have any more questions, and we'll take one or two more questions in case you get those in. But I think this has been really great because there's a lot. I mean, we could talk about like for hours, right, about Microsoft SQL, just SQL in general. Do you have where are you on the internet that people can find more information? Because you talked about your blog and stuff like that.
Yeah, I've got multiple articles about running SQL Server in Docker containers and Kubernetes. That's on my blog at dbafromthecold.com. And also I'm on Twitter as well, at dbafromthecold. So if you have any questions, please feel free to reach out because I'm always willing to talk about this stuff.
Yeah. Great. So the blog has resources. That's always nice. I'll put that in the chat.
If you just click the link there, there's the summary to my container series. And there's a whole bunch of stuff.
Oh, nice.
So I'll literally take you through running your first container, building a custom image, all the way down to SQL Server 2019 running there. And I'll take you through installing Docker, pulling down the image, spinning it up, persisting your data, taking you through everything there.
All right. Oh. Cool. All right, and Twitter, same thing. DBA from the cold.
That's it. Yep.
Nice and easy to remember. Well, thank you so much, Andrew, for being on the show. I'm glad you reached out, and certainly as we see more database technology advancements and new releases of Microsoft SQL, it'll be exciting to talk more about this in the future when we have more tools, more backup stuff, more replication stuff to talk about. I'm sure we could get into. So I'm looking forward to our next dive into databases and containers. So thank you.
That's great. Thank you very much for having me. Really enjoyed.
Yeah, and so for the rest of you that are watching or listening on the podcast, again, we're here every Thursday taking your questions, talking about containers and DevOps and the cloud and all that stuff. And don't forget to, if you want to support this show, check us out on my Patreon page, which is down in the description. And you can get all that stuff there, as well as links we will update later with all of Andrew's links to his blog and all the stuff we referenced in this. we will update as well later. So thanks a lot, and we'll see you next week on YouTube Live.